Hi class, this is Dr. Martino again. Today's short lecture will be describing the function of the baroreceptors, and we'll be using this graph to understand the function of the baroreceptors. So what are the baroreceptors? Where are they located? The baroreceptors are located at the bifurcation of the carotid arch. This is the point where the internal and the external carotids split. In this crook where the two split, the bottom of the V, you have these baroreceptors, which are the short time frame blood pressure regulators. In addition to these baroreceptors, you have additional cells in there that are called carotid chemoreceptors. Carotid chemoreceptors are the main oxygen sensors of the body, but they also sense carbon dioxide. We will not be focusing on these, as these will come up again in the respiratory physiology section. So let's talk about the baroreceptors. On the y-axis, we represent the inhibitory output, how much inhibition the baroreceptors are pumping out, going from 0, and you can imagine the top being 100%. On the x-axis, you have blood pressure from 0 to 160. You'll notice that this spot here represents a mean arterial pressure of about 90 millimeters of mercury. It's roughly, if you take about 120 over 80, you run it through a simple equation, you get somewhere between 90 and 195 millimeters of mercury. Okay, so that's our starting point. That's normal for most people. Now let's take a scenario where we increase somebody's blood pressure to 120. We increase it to 120. In order to understand what happens to the baroreceptors to correct this, you draw a vertical line as straight as you can up to the curve. When you touch the curve, that's the point that indicates how much output there is. If you take a look at the black dot and the red dot, you'll notice that the black dot is lower on the y-axis than the red dot. That means that the red dot signifies more baroreceptor inhibitory output. More baroreceptor inhibitory output. What that does is that inhibits more and causes the blood pressure to drop back to 90. Now, it does this in a couple of different ways. It inhibits more by increasing parasympathetic output, and it decreases sympathetic output. So it basically causes your blood vessels to dilate because of an increased parasympathetic and a decreased sympathetic output until your homeostasis is back to roughly 90 millimeters of mercury. So that's how it works when it goes up. So now let's take a look at what happens when blood pressure drops. You go from 90 to, let's say, 60. This point right here. You have a decrease in blood pressure. You go up to the line. That's the point that indicates how much baroreceptor output there is. And you can see that at this point, there's much less baroreceptor output than there was at the beginning. What does this do? This ultimately causes an increase in blood pressure back to 90. How does this occur? Well, there is a decrease in parasympathetic output. There is an increase in sympathetic output. Now, something we mentioned briefly when we were looking at glycinergic and GABAergic interneurons, which are inhibitory, was this idea of disinhibition. When you inhibit an inhibitory system that is called disinhibition. So, pretty straightforward. Blood pressure goes up, you get an increased output of the baroreceptors, which inhibit more, decrease sympathetic output, increase parasympathetic output. They will lower your blood pressure back to where it started. If you get a decrease in blood pressure, you get a decrease in the inhibitory output of the baroreceptors. You get a disinhibition, and that disinhibition is the sum total of a decrease in parasympathetic output and an increase in sympathetic output. Now, one side note, the reason that research on trying to correct hypertension in the United States, high blood pressure, failed when people studied the baroreceptors was because the baroreceptors over time adapt. So let's take the first instance again. Let's assume that blood pressure rises. Let's assume that blood pressure rises. That blood pressure rises from 90 to 120 again. You go through the same loop and it comes back. But let's say that over time, whatever it is that's causing the blood pressure to rise, okay, usually it's some kind of obesity, unless it's genetic, right? Some kind of obesity, some kind of other disease. That disease, that obesity, that weight gain doesn't go away. Over time, the baroreceptors get tired. They get tired. And your body keeps wanting the blood pressure to go back to 120. The baroreceptors bring it back, and so on and so on. But over a short period of time, what will happen is that the baroreceptors will stop fighting you. Now what will happen is they will reset normal to be 120. They will only fight you so long because they're only a short-term fix. And once the baroreceptors realize that this is a long-term problem that they're not capable of fixing, they just allow the blood pressure to reset, and then they can function to the right or to the left of this. And they don't have to use as much energy. The same thing would be true. The same thing would be true if you kept lowering the blood pressure. Eventually, the baroreceptors would realize, okay, 60 is the new safe place to be where I can do the least amount of work. And so I'll reset normal to that. So in both of these cases, it's bad, right? Because the mechanism that we have to adjust blood pressure changes in the short term still works, except it's working at either a higher or lower blood pressure, neither of which is optimal for our existence. And so the baroreceptors are not the key to curing hypertension. Early on, it was a field of research that was promising, but once it was determined that they adapt, they became problematic, and people switched to other lines of research to investigate and try to ameliorate or prevent hypertension. So really, really interesting. That's how the baroreceptors work. Hopefully that explains it in a way that you can understand. But using and memorizing this graph is a tool. So this should be your friend. I would memorize this graph and look at this video and watch this video as many times as you need to. I hope all of you are doing well. Have a good evening. Take care.